Okay, welcome to outcome A3. This is from section 5.3. This is dealing with radical equations. Ooh, this is embarrassing. What is eradication? I don't know. I should say radical. All right, anyway, for the key terms, you can see that last section, section A2. Okay, so radical equation that is the worst looking spelling ever. That says a radical equation is an equation where a variable appears inside a radical. And we're going to look at three examples here for the lesson. And there's a basic technique here which can be summarized this way. To solve a radical equation, you simply isolate the radical, square both sides, solve what results, and then you have to check your answer because there could be what's called extraneous solutions. These are extra solutions that are in fact false solutions. Okay, so let's try the first question together. So I'm going to isolate the radical, so I'll leave root 3x minus 8 where it is. And I'll subtract 1 from both sides, so 3 minus 1 gives me 2. Okay, now I'm going to square both sides, so I'll square this side, square this side. And now I end up with no radical, because a radical squared, a radical times itself, is just the radicand. And 2 squared, well, that's 4. Okay. Remember we saw this earlier, this idea that if you square a square root, well, it just kind of eliminates that operation. From here, it's just a matter of solving this linear equation, adding 8 to both sides, gives me 3x equals 12, and so therefore x equals 4. Now that seems like the right answer, but you actually always have to plug it in to check, because squaring both sides may have caused an error. So if we plug it in, we get the square root of 3 times 4, that's 12, minus 8 plus 1 equals 3. Okay, let's see. That's the square root of 4 plus 1, which is 2 plus 1 equals 3. And if I count it on my fingers, yeah, that checks out. Okay, so I can be absolutely sure that x equals 4 is the correct answer. But I have to check every time because this idea of squaring both sides can produce errors. I'll just show you that on the side here. Let's say I started off by saying 2 is equal to negative 2. This is clearly wrong. Oh my. But I'll just prove it to you by squaring both sides. If I square both sides, hey, I get 4 equals 4. So there. Well, no. Squaring both sides can turn something that's incorrect into something that looks correct. So every time we square both sides, we have to be very careful and make sure that we check to make sure we don't create something that's in fact a false positive. Next equation. This one, the technique is to isolate one of the radicals, like x minus 1, and then for the other one, we're going to have to kind of leave it in limbo for a little bit. You'll see what happens now. This time when I square both sides, something interesting will occur. On the left side, well, that's great. It's just x minus 1. What's going to happen on the right side? Well, 5 times this radical is the same thing I should recall, 5 minus this radical squared is the same thing as this. Wow. That's quite an expression. So here we go. 5 times 5 is 25. 5 times the negative radical is negative 5 times the radical. 5 times the radical again gives me 5 times the radical. Again, both of those are negative. And then finally the radical times itself will just give me the radicand. Let's combine stuff on the left side. And combine stuff on the right side. Okay, so I have 25 and 4, that's 29. That's these two. I have an x, so plus x. And then I have negative 5 and negative 5. I have negative 10 of these radicals. Okay, moving things over then, so as to isolate the radical. I'll leave the radical on this side. I'll move the other stuff over. X minus x. Hey, that cancels. And then finally, negative 1 minus 29 gives me negative 30. Okay, I could square both sides, but before I do that, I'm just going to do a really quick move here to make my life a little easier. I'll just divide by that negative 10. And doing that actually helps. That's going to give me 3 equals this radical x plus 4. You see what I've done? All that work. I've now created an equation with one radical. I now have to keep proceeding from here. I'll square both sides. 3 squared is 9. The square root of x plus 4 squared is x plus 4. Subtracting 4 from both sides, I get x equals 5. And finally, I'm almost done, but maybe I've produced an error. It's entirely possible that this is an error. So every time I square both sides, I have to go back to the original equation and check. So I'll check. Okay, so this gives me the root 5 minus 1 plus the square root of 5 plus 4. And we'll see, does that equal 5? Well, this is now square root of 4 plus square root of 9, which is 2 plus 3. And so in fact, that's 5. And it does check out. So now I can have some confidence that in fact x equals 5 is our solution. Okay, here's a final example. I'll start off by shifting that 1 over, so I'll have the radical isolated by itself. And x minus 1 over here. Okay, I'm going to square both sides. Squaring both sides over here, squaring the left side just gives me 4x plus 8. On the right side, well, that's going to be x squared minus 2x plus 1. Okay, I'm going to move everything over to the same side of the equation, and that gives me x squared minus 6x minus 7. I can factor this. That gives me 0 equals x minus 7 times x plus 1. This allows me to get two solutions, x equals 7 and x equals negative 1. Hey, the phone's ringing. Isn't that exciting? Yeah, this is the video in which the phone is ringing. This is so much fun. Anyway, I'll just keep letting it ring and we'll keep going. So I have to now plug these two results in and see if they work. It's actually possible that both of them are extraneous, and in fact there is no solution. We'll start by checking x equals 7. It's going to be 1 plus the square root of 4 times 7 plus 8 equals 7. Well, that's 1 plus, it's the weirdest looking plus ever, 1 plus the square root of 28 plus 8, 36 equals 7. That's 1 plus 6 equals 7. Hey, that checks out. So I can be confident the first solution is true. We have to keep checking. Check x equals negative 1. So I'll end up with 1 plus the square root of 4 times negative 1 plus 8 equals negative 1. So that's 1 plus 4 times negative 1, negative 4 plus 8, 4 on the inside there. That's 1 plus 2 equals negative 1, and so therefore 3 equals negative 1. That's not true. 3 doesn't equal negative 1. So in fact, this solution is what we call extraneous. It's a false positive. The only solution is x equals 7.